Okay, for Algebra 1 today, we are doing 3.8, which is mixtures. All right, so again, we're still kind of dealing with the same thing that we've been doing the past 2 days in class and using these tables to help us. So just another way um, of moving them, of combining them and using these tables, because we can use the tables for all kinds of things, but the tables are to sort out our thinking. So mixture problems are going to involve combinations of different substances. And so to solve them, we're going to make a table, like the coin table that we did way back when and we came back to with the money, the motion tables that we did yesterday, and the interest problems that we did the day last week as well. So all of these. So we're going to do like we did yesterday. We're going to read through the problem. We're going to pick out the important information and put it into the chart. And then we're going to try to solve from there. Okay, so a feed store owner wants to mix, he's going to mix corn and barley to make 150 bushels, BU is bushels, of silage additive for cattle feed. So that's why we've got corn and barley here, and this mixes the silage. And so I have in my table the number of bushels, and I put 150. Okay, so if the corn costs $3.80 a bushel, and the barley costs $2.60 per bushel, that's a unit rate for each of those, how many bushels of each grain would he mix, to yield an additive, that's the mixture, right? Would he mix to yield the additive worth $3 per bushel? Okay, so again, I have my number of bushels. I don't know how much corn or how much barley. I just know there's 150 total. I know the price per bushel. My corn was $3.80, so I put it in there. My barley was $2.60, so it's in there. And the additive worth, the silage or the mix, is $3 per bushel, and I put that in there. Okay, so I need to use a variable and fill in my number of bushels. Okay, here. So I said, let's C equal the number of bushels of corn. That's why I chose C. So corn is going to be C. So how many, what are we going to put in for the number of bushels of barley? Remember, we know that it's our 150 is how much we have total, and then part of that is our corn. So to get our barley, we're going to put in 150 minus C. Okay, we also have these dots and some equal sign to help us know that the number of bushels times the price per bushel is going to give us the total cost. So we're going to fill out this column by doing the math, just like we did yesterday with principal times rate times time equal the interest. So this is going to be 3.8C. The next one we're going to have to do we'd have the distributive property. It's going to be 2.60 times the quantity, 150 minus C. And the last one, 150 times $3 is $4.50. Okay, so then I've got the table, but now I've got to figure out, well, how do I put this together into an equation so I can solve it? So again, we have to look at what's happening in the problem and understand what's going on in the problem. So we've got this feed store owner. He wants to mix corn and barley together, right? He wants to mix the corn and barley. Well, when you mix them, are you adding? Are you subtracting? Are you multiplying or dividing? You're adding. So he wants to add these two, and he wants to get this mix. That's exactly what we do in our equation. We're going to add those two things together to equal the last one. So we're going to have 3.80C plus 2.60 times the quantity, 150, minus C equals 450. Okay, I'll help you out there a little bit even. If you could clear the decimals here if you wanted, but again, you get to use a calculator, so you don't have to clear the decimal. It's a strategy that you can use, but not one that you have to use, especially since you have the ability to use a calculator. So let's make it a little simpler. So this is going to be 3.80 C, or you can just do 3.8. Again, it doesn't matter. Plus, we need to distribute. 260 times 150 is 390. Minus, okay, we're distributing, 2.6 C equals 450. From there, you can solve, right? We have like terms, 3.8 C minus 2.6. So we've got 1.2 C plus 390 equals 450. Subtract 390. So 1.2 C equals, what's 450 minus 390? Okay, hopefully you got 60. Now we would divide by 1.2 and see, whoops, I don't know what happened to my thing there. Whoop. Okay. All right, so I'll write it over here. C equals, what's 60 divided by 1.2? C equals 50. All right, so it's 50 bushels of corn even. So that doesn't answer the, like, one, yes, that checks out. I gave you the answer for that. But it says how many bushels of each grain would he mix? So he would mix 50 bushels of corn. He wanted, remember, 150 bushels total. So to find a barley, we were going to take 150 minus C. So 150 minus 50 is 100. So 100 bushels of barley. That's your final answer. But again, like I said, so this is probably going to be the only one I work out, because your answer, part of your solution, like to check your work, is here. And if you get that part right, then you know the rest is going to be correct. And you can solve the question and answer the whole thing. Okay, let's go to the next problem. Example 2. All right, so example 2. Nickel silver, often used for coating tableware, is an alloy containing 15% nickel along with copper and zinc. So this is that nickel silver. How much pure nickel, so now we've got pure nickel, must be melted with 70 pounds of nickel silver to make an alloy that's 20% nickel? Okay, so some things that we've got in our table we set up. I've got nickel silver, the pure nickel, and our alloy that we've talked about. Okay, so nickel silver is here, the pure nickel, and an alloy. Okay, so then it talked about, if we go back through, nickel silver is often used for coating tableware, is an alloy containing 15%. So we have the percent of nickel. In our nickel silver, we know that's 15%. And they told us in the alloy that that's 20% nickel. And how much pure nickel must be melted? So let's think about this. Pure nickel. If it's pure, what percent of it is nickel? Okay, hopefully we got 100%. Right? It's pure nickel. It's 100% nickel. But how much pure nickel must be melted? We don't know how much. We don't know the pounds. Okay. To make the alloy that's 20% nickel. So at this point, we've kind of put everything into our chart that we can put in there. Right? Like, okay. So now we need to start coming up with some variables to put in there. So I gave us P equals the number of pounds of pure nickel. So pure nickel The pounds, we're just going to put P, which means our alloy is going to be what? So again, think about the context of the problem. We're taking nickel silver and we're melting pure nickel with it to get an alloy. So we're adding these two to get this total down here. So that's going to help us fill in the pounds of metal, because we're going to have 70 pounds of nickel silver plus however many pounds of our pure nickel to get our alloy. Well, now that we have that, we can fill in the pounds of nickels, because the pounds of metal times the percent of nickel is going to give us the percent, or the pounds of nickel. Remember, it's kind of like that percent equation. All of these are manipulating that percent equation. We have the percent of the whole is going to equal the part. All right, so 70 times 15, okay, would go here. And again, this is percent, so let me change these. This should be 0.15, 100 is 1.0, and 0.2. Sorry about that. I don't know why I didn't put the decimal in there for you. But let's do this then. So 70 times 0.5 is, or 0.15, pardon me, goodness, is what? Should have 10.5. P times 1 is just P. And then we have 70 plus P times 0.20. Okay, so this one again is going to be the distributive property, right? So we can have the quantity 70 plus P times 0.2, but we have to distribute it. So 70 times 0.2, that 20%, is 14, plus, and we distribute again to the P. So plus 0.2 P. Okay, so we already talked about what's happening in this problem. We're adding the nickel silver. That's what we said, right? We're adding the nickel silver to the pure nickel. So we're adding these two together. So 10.5 plus P equals the last part there. So equals, we just want that last part, 14 plus 0.2 P. All right, and you can solve that and find out the number of pounds of pure nickel. You can solve this equation. You have a P on the left and a P on the right. You have to get like terms together. You have 10.5 or 10.5 and 14. Get those like terms together as well and solve for P. And you should get that P equals 4.375 pounds. Okay, so hopefully you got this down, and talking through these word problems is hopefully helping, because again, you can do the math. And you can set it up too, like I have no doubts, but I understand that using these tables is difficult. All right, let's look at the next one. Example 3. The local dairy farmer has 2 milk cans. One has cream in it that is 35% fat. So let me see. We've got cream that's 35% fat. How many gallons of skim milk, which is 0% fat, and cream should he mix, so he's mixing them, so we're doing addition, to make 50 gallons of milk that's 14% fat? Well, that is an interesting one, right? Maybe not one that we've done a whole lot. So let's check it out. All right, so we have cream and skim milk that we're adding together to equal our mix. So that's going to help us set it up really well. Then this problem is a lot like the one we did before. We had the cream that's 35% fat, so that's going to be here, okay, 0.35, with how many gallons of skim milk, which is 0% fat, so that's just 0, but we've got that in there. And we want 50 gallons, so that's in our gallons of milk, That's 14% fat, so 0.14. So we got 50 gallons and 14% fat. So we've put all of our numbers into our table again. And I know that you're going to have to set up your table on your own for your homework. So again, I just look at what we have. I had gallons of milk, and then we had percent fat. And so that's going to, when I multiply those together, it gives me the gallons of fat. Okay, instead of the gallons, the whole, right? This is the whole times the percent equals the part. All right, so now we need some variables. We're going to use C to be the gallons of cream. So if the C is our gallons of cream, what is our skim? Again, this is just like example 2. We're going to take the total. So it's going to be 50 minus C is how much cream we're going to, or how much skim milk we're going to use. Okay, so now we're ready to do the multiplication and fill out our last column. So we have 0.35 C for this one, 50, the quantity 50 minus C times 0, if that's distributed, just equals 0. And the last one, 50 times 0.14. Let's do some math there. So get out your calculator. And what is 50 times 0.14? Okay, hopefully you got that it's 7. All right, so again, we talked about we're adding these first two together. So we're adding these. My marker would change. There we go. So we're going to have 0.35 C equals 7. What? That seems like it's so simple to solve. Well, that's because it is. Like you got rid of all the other things. So you would solve this one. Okay, and when you solve it, you should get C, so the cream equals 20 gallons. Again, that's not your only answer. You have to go back and look at the question. How many gallons of skim milk and cream should he mix? So we've only got how much cream. You also have to find out how much skim milk. Okay, so don't just stop with making sure you have the right answer that matches what I have, but that will help you. Okay, then last one, example 4. A chemist has 2 solutions. Oh, if my paper would go. All right, so a chemist has 2 solutions. Solution A is 8% acetic acid. Solution B is 20% acetic acid. So I have percent acetic as one of my table, like one of my columns. If he wants 4 liters of an 11% acetic acid solution, so here 4 liters, that's why I have the liters of acid as a label in my for one of my columns. How much of solutions A and B should he mix? Okay, so then my last one, again, is I have the liters of acid, the percent of acetic acid. So now I have the liters of acetic acid. So this is my whole times the percent equals the part, just like we've been working on and manipulating that equation. Okay. All right, so let's plug the numbers in to the chart. So solution A is 8% acetic, so that's going to be 0.08. Solution B is 20% acetic, so that's 0.20. And he wants 4 liters, so I've got 4 here, of an 11% acetic acid, so 0.11. Again, I don't know why I didn't put those in there when I wrote it. I apologize for that. Okay, so do we know how many liters of A and B? No, but we're going to use A for the liters of solution A. So if this is A, what am I going to put for B? Awesome. I hope somebody just shouted it out anyway, that it's 4 minus A, right? Because we know the total. Okay, so now we can fill in our last column by multiplying the first 2. So we're going to have 0.08A. We're going to have the quantity 4 minus A times 0.20. We're going to have to distribute. So let's get that distributed and see what we get. So 4 times 0.20 is good, 0.8 minus, okay, again, we're distributing, and so let me put, might be better if we had a 0 there so we know it's 0.20 and not times 20. So that equals minus 0.2 or 20a. And the last one, 4 times 0.11 is 0.44. All right. So now what's happening in the problem? He is mixing, right? If he wants 4 liters of an 11% acetic acid solution, how much of solution A and B should he mix? So he's mixing it. He's adding them together to get the denominator. So 0.8A plus, okay, and we're just taking the second portion, that expression there, plus 0.8 minus 0.2A equals 0.44. Again, you can clear the decimals if you'd like. If you don't have a calculator, clearing the decimals is a great strategy. But if you have a calculator, combine your like terms, right? 0.8A minus 0.2A and solve your equation. And you should get that A is equal to 3 liters. So if you don't get that, you know you've made a mistake. Okay, so you can solve those and then get started on your homework. Your homework is on the front there. So page 137, numbers 1 through 25 odd. So not a whole lot of problems because I know they take up a lot of time to do and think out, but not all of them require a table, I don't think. Some of them are a little simpler. But good luck with your tables, and I'll see you tomorrow.